Okay, so we're looking at M1 2003 January paper, and we're doing question 8. Okay, so I'm going to go straight into this. I'll let you read the question in your own time, but it talks about particle A and particle B. First of all, we're going to analyse particle A and particle B separately. So I have particle A, which has tension acting that direction. We have a mass, so we've got 0.8 g acting down, and we have a reaction force acting up, of course. And particle B, we have the same tension acting up. We have 1.2 g acting down, and of course both of these particles are accelerating at the same rate, because it says that it is released from rest, which means that it is moving. Okay, so the first question says calculate the tension in the string before B reaches the ground. So I'm going to resolve A in the initial direction of motion. So we know that it's moving, so the sum of the forces equals our mass times acceleration. Now we only have one horizontal force acting, so we've got T equals M, which is 0.8 A, and I'm going to call this equation 1. Now doing a similar thing, so resolving in the direction of initial motion of B, F, the sum of the forces equals mass times acceleration. So in a positive direction we've got 1.2 g, then we've got a minus T equals 1.2 A, and I'm going to call this equation 2. So it wants me to find out what tension equals. I think I'm actually going to find out the acceleration first, so I'm going to sub 1 into 2. So I've got 1.2 g minus T, which is 0.8 A, and that equals 1.2 A. Rearranging, so I've got 1.2 g equals 2A, so A equals 1.2 g over 2, or A equals 0.6 g. I'm going to put down a numerical value for A, so A equals, put into the calculator, okay, 5.88 meters per second squared. Okay, so that's my A, and now I can sub. I'm going to continue working down the page. Okay, so I can sub A into, put it into equation 1, it looks like the easiest. So we've got T equals 0.8 times 5.88. So T equals, calculator again, 4.704, and I'm going to put it into 3 significant figures, so I've got 4.70 newtons, don't forget the units, and it's to 3 significant figures. Okay, so that's part A done. Part B, the time taken by B to reach the ground. So this is going to be suvat, so part B. So I'm going to redraw a diagram and put suvat on it. So I've got B, particle B, which is 0.6 meters above the ground, and it is accelerating towards the ground at, what did we say, at 0.6 g meters per second squared. Okay, so looking at SUVAT, S is 0.6 meters, U, it is released from rest, so it is 0 meters per second, A is 0.6 g meters per second minus 2, and T, that's what I'm looking for, so I don't really care about V. S, U, A and T, so an equation which involves all of those would be S equals UT plus a half AT squared. Substituting and solving, I've got 0.6 equals 0 times T plus 0.6 GT squared over 2, and so I've got 1.2 equals 0.6 GT squared, so 1.2 over 0.6 G equals T squared. So I've got T equals 1.2 over 0.6 G. What's the square root of all that? I could simplify the 1.2 over 0.6 obviously, but I'm putting it into a calculator, so I'm not going to. T equals 0.45175 and some other stuff. So T equals 0.452 seconds to 3 significant figures. Okay, so that gives us B, the time taken. C, in a refinement to the model, the coefficient of friction is now 1/5. Find the time taken by B to reach the ground. Okay, so I basically have to do the same thing all over again, apart from I can miss out this little bit here, but I still have to do it in 3 steps. So first of all, I'm going to redraw my force diagrams, my sketches. They weren't really force diagrams, sketches. So I have particle A, which is being pulled by tension. It is now being resisted. It's moving, so it is F max. We have a reaction force, and we have 0.8 G. That is an 8. Believe me, that's an 8. And we know that it is accelerating with some acceleration A. Now the fact that we've got friction means the acceleration will have changed, so we need to work out the acceleration again. And mu, we're told, equals 1/5. Then we have particle B. That still has tension acting up, it still has 1.2 g acting down, and it has this new acceleration here which is linked to that. Okay, so looking at particle A first of all, resolving in the direction of motion. It's moving, so we've got the sum of the forces equals mass times acceleration. Now we have T acting in a positive direction, and we are taking away F max, and that is equal to 0.8 A. Okay, now we know that F max equals mu r. We know what mu is, so F max equals what's that? Don't know what that is. R over 5. We can work out our reaction force by resolving vertically. Resolving vertically, it is not moving, so that we know that the sum of the forces is going to equal 0, because it's not moving up or down, it's only moving horizontally. So we know that 0 is going to equal R minus 0.8 G, so R equals 0.8 G. I can sub that back into F max, so let's get rid of the diagrams there. F max now equals 0.8 G over 5, and I can sub that into here, so T minus 0.8 G over 5 is equal to 0.8 A. Okay, I'm going to call that equation 1. Particle B, well, again, first of all, resolving in the direction of initial motion. So the sum of the forces equals mass times acceleration. Sum of the forces, we've got 1.2 G acting in a positive direction, minus T is equal to mass 1.2 times acceleration. And I'm going to call that equation 2. So I've now got 2 equations and 2 unknowns. A little bit more work than in section A, but they are giving you more marks, so you have to work a bit harder for it. Okay, so I'm going to rearrange 1 to make T the subject. So T equals 0.8 A plus 0.8 G over 5. I'm going to call that 1, 1, and I am going to sub 1, 1 into 2. So equation 2, 1.2 G, 1.2 G minus T. I'm going to put this all in brackets first of all, so 0.8 A plus 0.8 G over 5, and that's equal to MA, which is 1.2 A. Okay, so now I have one equation, one unknown. I can solve to find out what acceleration is. So let's do 1.2 G minus 0.8 A plus 0.8 G over 5 equals 1.2 A. I'm going to add 0.8a onto both sides first of all. So I've got 1.2g plus 0.8g over 5 equals 2a. Then I'm going to divide through by 2. So I've got 0.6g plus, well, that's going to be 0.8 over 10, so that's 0.08g equals a. So a is going to equal 0.6 take away 0.08, that's 0.52g meters per second minus 2. I'm not going to work that out because I'm going to sub g in right at the end, but now I can, just like on the first one, once I had the acceleration I used suvat, so I'm going to use suvat again, and I'm going to draw a new diagram. So particle B is still 0.6 meters high. It is accelerating at 0.52 g meters per second minus 2. Let's drawing the ground here. Okay, so we've got SUVAT. We know that S is 0.6 meters, U is 0 meters per second because it is still being released from rest. V, well, we're not going to need V. A is 0.52 g meters per second minus 2, and T equals time, because that's what I want to know. Okay, so I'm going to use the same suvat equation as before. So S equals ut plus a half at squared. So 0.6 equals 0 times t plus 0.52 g t squared over 2. So one unknown, one equation. We've got 2 there, so we can do 1.2 equals 0.52 g t squared. Just finding my calculator. Okay, so yeah, so back to 1.2 over 0.52 g equals t squared. So t equals 1.2 over 0.52, square root of all that. So t equals 0.485261 and so on. And we know that we have to simplify this, so t, which is time taken, is 0.485 seconds to 3 significant figures. And there we have question done. A, B and C. Took me 4 pages, but I was writing quite large and I was wasting a lot of paper, but you will get that amount of paper in the exam. Don't worry about wasting too much paper. If there's anything you want to see again, rewind the video or have a look at the PDF of this, which is going to be available for download as well. Okay, thank you, that's me done. Thank you, bye.